My name is Brent Williamson. Today I'm going to show you the Mechatronics Trainer, the assembly line system. This project was intended to simulate like a maintenance technician position. So I got the project with all the PLC programs already in the PLCs. I didn't have to build any of the stations. It was just when I got it, the parts wouldn't go from the start all the way to the assembled part at the end. So I had to work through each station, get them working, fix PLC problems, pneumatic problems, regulate the airflow so the things worked right. Um, so some of the system requirements for this project were 120 volt for all the trainer power, and then all the control power was 24 volt on DC. There was pneumatics, so about 60 psi of air for all the solenoids and cylinders that run this project. And then there was Ethernet. So I started with serial communication between the PLCs, or like physical I/O connected wires. So the PLCs would send bits to the next one. Then I had to convert it over to Ethernet. So, like I said, I got the project. It wasn't working, and so I worked through, got it. So the product made it from the start to the finish, all assembled, and then I recorded the time that it took. And then from there, it was making improvements. So I got a mobile HMI, so it's on a cord. You can move it around. It's not mounted to a solid surface, so you can go to each station with the HMI. And then I had to convert everything to Ethernet communications. So I got rid of the serial cables, and then used produced and consumed tags for the PLCs to talk back and forth and tell the next station to go, or the previous station that it's ready. And then for added quality and like a better system, I added a Cognex camera, inspection camera, so that I can check if parts are there. For example, in station 5, there's no sensor to see if there's a knob in place ready for assembly, so I use the inspection camera for that. And also, I use the inspection camera to see if there was a knob correctly assembled on the valve body before I sent it to storage. So it's like a quality control. Some of the components of this system are the 7 stations. So the Amatrol trainers that were already built, and then they each come with their own compact Logix PLC. So there was communication back and forth between them. There was a separate program in each PLC, and then there is the Cognex inspection camera, like I stated before, and then the Fanuc robot, which was used in Station 5 to move some parts around. Now I will show you the stations in operation. Station 1, once the start button is pressed, the plunger will push a block out from the stack of raw blocks, and the vacuum will pick it up and transport it to Station 2. Station 2 is the gauging station, so it's checking to see if there's a dual port on the side of the block with a sensor, and then it passes under a sensor that checks the height of the block. If it's a good block, it'll pass it to the next station. If it's a reject block, it'll eject it into the reject bin. Station 3 is the indexing station. It's the first sensor is a through beam sensor, checking to see if the port is oriented in the right place on the block. So the acrylic blocks have the main port offset from center. So if the through beam sensor doesn't see through, it's going to send the block to the flipping station. As you see in this video, it flips the block over so it's oriented the right way, and then it'll spin around and push the block onto the next station. Station 4 is the queuing station. So first thing, when the blocks come off the previous station, they pass underneath a sensor that's checking to see if the block is aluminum or acrylic. The acrylic blocks will continue straight, and if it's aluminum, a pusher will come out and push it to the far edge of the conveyor, and then the blocks go into like a holding where they stack up and like queue them so they're ready for the assembly station. Since the assembly station takes a little bit longer, then it lets one block through at a time to sit in the waiting spot for the assembly station, and where the robot picks it up from. There can be a max of 3 of one kind of block in the queuing station at a time before it won't let any more come in. Station 5 is the assembly station. So first thing, the camera is gonna take a picture and inspect to see if there's a knob waiting to be assembled. If there's not, it'll fault the process and you'll have to reset and put a knob in place. If there is a knob waiting, it'll tell the robot to grab a part from a previous station and put it on the assembly platform where one of the two types of spools is inserted, and a bolt is inserted into the spool. Once that's completed, the assembly is slid down a little bit further to where the bolt is started onto the knob. Once the threads are started, the robot picks it up again and places it onto the next station. After the robot places the assembly onto the next station, it's going to grab a knob from the knob holder and place it back on the platform so it's ready for the next assembly. Station 6 is the torquing station, where the knob is torqued onto the bolt, and if the knob is not correctly placed in the previous station, the knob will fall off before it gets into the station. So that's where the inspection camera comes into play as well. It's checking to see, once the torquing station is done, to see if the knob is correctly placed. The last station, Station 7, is like the storage and sorting station. So this station takes the inspection results from the previous station camera inspection, and it sorts the good parts from the bad parts, as well as the aluminum valve bodies from the acrylic valve bodies. The first 2 rows are aluminum valve bodies that are good parts. The third row is the acrylic ones, and then the last row is all the reject parts that are rejected by the inspection camera. Now I will show you the complete process from start to finish. This is the Insight Explorer 6.5.0 software that I use for the Cognex Micro 1100 camera. So the camera is taking pictures when it's triggered through Ethernet, and it's checking for certain parts. So, for example, before Station 5 will start assembling, it checks to see if this knob is sitting in the correct spot. If it's not, it'll fault. So you can see the pattern that it's looking for is right here, and then the area that it's checking for is this green box here. Then there's also another pattern. You can't see it because it hasn't been triggered, but when the block's sitting in the torquing station, it's looking to check and see if this image is on there, so it's looking for the knob, and it gives it a pass or fail for the last storage station, so the reject parts get sorted from the good parts. This software has to be running in order for your inspection camera to work. I wasn't able to get this hooked up to the mobile HMI, but it does operate. You just can't see the camera images unless you are on the computer itself. So that's an overview of the inspection camera and the software that it uses. So I'm going to show you the HMI and some of the features that it has. There's built-in security so that only certain users can get to certain things. So as the default user, I try to go in the master control. It's access denied. So I'm going to log in as a user. Now I can get to the master control. So this screen is for controlling all the stations at one time. So I can push the reset button and reset all the stations at once. Switch them to auto mode, or start and stop all the stations with one push of the button. There's also the individual stations down here, so you can go to those pages and see more detailed information. And then the Ethernet active button, that is so when you're communicating with Ethernet mode using produce and consume tags, you can activate that. Otherwise, if it's in this mode, you'll have to have the serial cables plugged in for the physical I/O to go back and forth between the PLCs. So I'm going to activate the Ethernet. We'll go to the overview page. So this shows the status of all the stations. You can see which mode they're in. If I go back to the master control, hit auto, and then you can see it switches all of them from manual into the master auto mode. You can see if there's a fault active, and these status indicators match the lights on the front of the trainers themselves. If I go into the individual station screens, there's start and stop buttons, auto mode, and reset. For the individual station itself, you can control one station with the buttons on that specific screen. There's also status indicators, as well as like an event and status display in the center of the screen to tell you what's going on with that station. And there's a number of counters on the different stations to keep track of parts, what's coming in and out. I can walk through some of the stations. They're all pretty similar, just different counters. And then we get to the queuing station. Again, there's some parts counters, acrylic, aluminum. So this is where it's sorted into the two different types. And then they're like put in holding for the assembly station with the robot. So you can see how many parts you have in holding. You can have a max up to 3 before it won't let any more come in. And then if that count gets off, or you need to clear out the parts, you hit reset and it gets rid of all your parts in holding, and then you can see the status of the machine. I want to go through a few of the other ones. They're all pretty similar. The robot status is on station 5, so you can see if it's faulted or if it's enabled and running. This is also where the robot reset is and the robot start. So this is the only place where you can reset the robot and start the robot. It can't be controlled from the master control station for safety purposes. So you have to go to this station to start the robot by itself. We'll finish the rest of the 2 stations. Just again, different counters. And then the last one shows the storage slots that we have. The first 2 are aluminum parts that are good. So you can see that it shows how many are sitting in that slot. The third one is the acrylic, and then the last one is the reject parts. So if the knob isn't put on, or if the inspection camera doesn't pass it and puts it in the last bin. If I take one of these parts out of here, say for shipping or whatever, I can offload the part and it keeps the count accurate because there is fault built in. So if the slot gets full, it alerts the operators that you have a fault condition. I can also clear all the rows If I have all my storage rows cleaned out, I just hit clear rows. And if I don't want to sort them, I just hit the sequence storage mode. So it's just going to stack them in one at a time all the way across the storage when no sorting. I want to sort them, so I'll turn that back on. If we go back to the overview page, we can see some of the other features. The alarm history. This just shows what alarms has happened. If you want to clear them, acknowledge them. So you can go to this for the alarm history. And then the last page is the inventory. So this keeps track of all the parts that come into the stations, and then at the end, you should still have the total amount of parts when you add up the bad parts or parts that got rejected. So you can keep track of parts that are going missing if the counts aren't going all the way through the stations. You can also reset all the counts from the screen. You have to reset each station one at a time. So you can set them all back to 0. Again, this is only for certain users to be able to reset the parts and see the counts. So just keep track of inventory and what's going on with your system. If there's parts that are getting taken out of the system and partway through, you'll notice when those parts are missing. That's pretty much the extent of the HMI, and just as a great way to see what's going on with your stations, and also be able to run these mobily. With that mobile HMI, you're able to carry it around and to the individual stations, start and stop them, see faults. So it's a great visualization of your process. Some of the safety features of this project are when the serial cables are connected between the stations, when one e-stop is pressed, they all go off. So when I added the mobile HMI, I had to figure out how to tie that e-stop into that circuit as well, so it acts just like the other ones. However, when the Ethernet mode is enabled and you unplug the serial cable, the e-stops will not all go off if one is pressed, because it breaks the physical wiring circuit of the e-stop circuit. Well, that pretty much wraps up the Mechatronics Trainer project. Thanks for watching. Hope you enjoyed it, and I just wanted to say a special thank you to instructors Dale Moak and Josh Rankin for all their hard work in the past 2 years and everything that they've taught me. Thank you.